Looks like they're starting to close the doors, so we'll go ahead and get started. How's everyone doing today? Doing good? All right, who here this, well, I was going to ask some questions, I just totally forgot them. I'll put out a disclaimer right now. So I'm from the United States. I'm a little jet lagged, but that's okay. I've had like 3 or 4 of these to try and keep me awake, and then I'll stop drinking them after I get my presentation done. But who here, this is their first PHP or any type of tech conference at all? Okay, awesome. How many of you is kind of maybe like a second or third? And then how many of you have been to like 5+? Okay, awesome. Nice good mix. All right, so we have a lot of material to cover in 45 minutes, so we'll go ahead and get started. Very briefly about me, I'm the Director of Development for a company called Deseret Digital Media. We basically do the digital properties for several media companies in Utah. I'm also currently the president of the Utah PHP User Group. I've been a PHP developer professionally for about 8 years. I'm also a goofy and tired dad with a newborn. And I have a Git repo that has all the kind of code demos that we'll look at. You can check it out either now or afterwards. You can follow along or you can check it out afterwards. I'll also post a link for the slides. You don't have to worry about taking notes or anything. The slides will be available online. Normally, I like to try to make really nice looking slides, but my work gave me this template, which looks really, I don't really like it a whole lot. And this guy came along a couple months ago. He keeps me pretty busy, so all my time where I'd usually spend making really nice looking slides went to him. So no fancy slides this time. Sorry, but that's okay. All right, so before we get started, who here would say in your work environment or whatever you guys are doing that you're already using some sort of worker system where you have asynchronous workers that are running? Raise your hand. A good portion of you. Very good. All right. Then I'm assuming the rest of you haven't had a chance to use them yet. Okay. So what I want to do is I want to first identify a problem that you'll typically face in web development, especially if your application starts growing bigger and you're starting to do more things. We'll start off with the concept of a blog or some sort of publication. The project I work for is an online newspaper, so we post lots and lots of articles, and so typically you have some type of editing form or some type of utility or tool that you use to get your article all ready to go, and then you hit publish, and your application will do multiple things. And it'll probably save, your article to a database or some type of data store. And typically, when you're first starting off, that's about it. You save it to a database, and you display some sort of success page, and you move on. This could apply to a blog post. This could apply to a account creation, an order. You bought something on some type of e-commerce platform. But typically, as your application grows, you'll want to start doing more and more things in between pages. For example, you might want to post to Twitter and Facebook. You might want to send out emails to people who have subscribed to this particular topic. If you have a very high traffic site, you might actually want to go ahead and pre-warm your cache on the front end saying, hey, before this actually goes live, I want all my stuff cached if it's like a breaking news story that will have tons of people hitting it. You might want to update, we call them queues at work, but update different lists saying, hey, this article qualifies now to being these several different lists, but I need to push this article to these different queues. You might have to create just some images that you might have, you've uploaded one big master image and you want to, do some processing to get, here's a thumbnail, here's a portfolio image, whatever. You might do something to find related posts. That way at the bottom of your page, you want to save that, say, hey, go out, generate, and you might want to do another thing and another thing. And so you have all these things that you want to do in between the point of when you fill out a form and you display some sort of success page. And the problem is, this can get really slow. And it's typically a very linear approach. And because PHP is very linear in nature, it's kind of how things evolve and you eventually get to the state. But you run into a lot of problems when this gets more and more complicated. What happens if, the time going from save to success gets longer and longer? And then what happens if you get an error? What happens, this never happens, but what happens like if Twitter goes down? And that's like your first step. And then everything after Twitter that you wanted to have done, like fails and errors out, doesn't happen. And then what if you have a large site where you have hundreds or thousands of authors pushing articles, and every time they're trying to do that, or an author might have to do, push 100 articles through a day that they're managing and editing or whatever. If each time it takes a minute to hit the submit button and wait, it's very, very slow. It just doesn't scale well. So, a very common solution that to solve these problems is to split this job out, and let some sort of worker, like a PHP worker, handle it. And so, a PHP worker is basically a PHP process that typically you run from like the command line interface, a CLI. In our examples, we'll be talking about PHP and how to do workers in PHP, but in theory, you could be in whatever programming language you want. And they're going to listen to some sort of queue for jobs. And then whenever it receives a job, it's going to go and perform whatever actions it needs to do for that job. And then when it finishes, it sends its results off somewhere and then listens for more jobs. And so the workflow is you have your web application, and it's going to produce a job. And then you're going to have some sort of queue of jobs, so you have all these jobs queued up. And you say, hey, I want to take this job and push it to the end of the queue. Or you could push it to the beginning if it's like a high priority job. And then you're going to have some sort of worker that's independent from your web application. It could know everything or it could know nothing. It has zero dependencies on your web application to run. And it'll go ahead and listen to this queue of jobs. And so this queue will say, hey, I have a job available. Go ahead, send it off to the worker. The worker's going to take it, do whatever the job is, whether it's rendering an image, whether it's sending an API call to Facebook or Twitter or whatever it is. It'll go ahead and spit out its result and say, okay, I've finished that job. That's complete. I'm ready for a brand new job. And you can do the same thing over again. Have a job come in and throw out another result. And so this workflow is actually very, very, very simple. So if we have, our example of our blog post again, we're going to fill out a form. And then I forgot to update the slide, so I have one thing. So what I would do is fill out your form, we hit submit, and then you're going to do whatever the most crucial things for your application. So like saving to the database would be, I'd consider crucial. I want to make sure, I don't want to queue that up. I want to make sure that gets done. But talking to Facebook, Twitter, emails, all that stuff, I could care. I'm okay, if there's a problem with that, or if it doesn't happen immediately, or it's not mission critical. And so I'll queue up all sorts of jobs. I was up really late. I had fun with animation. Sorry, but I queue up all my jobs, and then I say, okay, my jobs are queued up. I'm not going to worry anymore. And then I'll go ahead and display this success page. And then these jobs, you can have workers with different priorities and different capacities or whatever, pulling these jobs and handling them separately from your application. And what that basically allows you to do is have a much more responsive user interface for your users. You can scale out your jobs. So if you have very resource-intensive jobs, you can spin up more servers that have more workers on it. You don't have to worry about slowing down your front end, typically. And it's pretty straightforward. Literally, the theory of having a worker is very, very easy. It's not rocket science. But a lot of times the devil's in the details. You're like, okay, how do we actually really do this when you sit down to go out and do it? So what we'll use is we're going to use PHP 5.3, and then I know when I originally submitted this talk, the abstract talked about Gearman. We're actually going to substitute it for Beanstalk, and I'll explain a little bit why later. But it's a queue system that has some that I really like. It's very simple. I like that. And then to talk to that queue, we're going to use a PHP library called Beanstalk. To manage those workers, there's kind of two options I have out there. Solo is kind of the poor man's way of managing workers, and then Supervisor, if you have full access to your server, then I recommend using Supervisor to do that. We want our workers to be able to report kind of status and data to us, and so we use Redis. It's kind of a key value store, NoSQL solution. And then to talk to Redis, we're going to use the Redis library. Are there any questions about this at all? It's pretty straightforward? Awesome. Okay. So everyone's going to say, wait, what about Gearman? Gearman's actually great to use. But it does require you to compile modules on your server. And so I've found that if you learn and can use Beanstalk, using Gearman, it'll be easy translation. It's very, very easy to use. And there's lots of talks about Gearman. There's a lot of resources about Gearman. And I kind of like Beanstalk. We get to kind of see a little bit more of the theory behind it. And Beanstalk's worked very well for us in our environments. Okay, so setting up Beanstalk, super easy. You can apt or yum install it. You could brew install, or I think there's even Mac ports install. If you want to do it on Windows, use a VM. You can check out Vagrant. I haven't found anyone who's compiled it on Windows, but using a VM is so easy these days. I'd recommend using that. I picked Beanstalk because it's the most tested PHP library. It has kind of most hardened. You can install it through Composer. There are other ones out there, but this is the one I recommend. And yeah, so the trick to making this all work is managing your workers. Putting stuff in a queue is really easy. That's not very difficult at all. Making sure that the system's up and running and your workers are consistently working, that's kind of the tricky part. And so, like I said, we'll talk about PHP workers, but in reality, you can use any language. In the past, I've had, at work, we had certain transcoding things that there's really awesome interfaces in Python for. So we had specific Python workers that would go in and manage all the transcoding for certain videos. And because the worker and that web application is completely independent of each other, they can be written in whatever language you want. And so when you set off to do your workers, a lot of times there'll be certain features you want to build in. You want them to be able to run for a very long time. That's typically something PHP doesn't do, or you typically don't use PHP for. Typically, PHP's fire and forget. You'll have a website, you run through all your PHP code, and it'll exit out. Whereas workers, you want to run a long time. You want your workers to be able to restart themselves. You don't want to have 50 workers out in production and realize you have a bug, and you have no way of telling them to restart themselves. That can be frustrating. So you want them to be able to restart it. You want them to be able to report their current status. It's really nice to be able to say, hey, these workers are working on this, or these workers are idle, or they're busy. You want them to do blocking requests, not polling. What that means is you want the PHP worker to be able to go out and say, hey, is there a job ready for me? And if there's not, I'm actually going to keep this connection open for however long you tell me until there's a job available. And what that allows you to do is you're able to have very, very quick responses for when a job comes in, to have very quick response times. And then you want them to be able to monitor their own performance. You can use things like Graphite, StatsD, things like that to be able to report how long certain jobs take or whatever to kind of monitor their own performance. And so that's kind of the overview of what we're trying to accomplish when we make our workers. So the first thing is to make sure they can run as long as you need them to. At some point in your application, you're going to have to tell it set timeout limit to 0, saying, hey, PHP, I don't want you to exit with an error after so long. I'll go ahead and exit myself. And then typically when my worker starts, I'll generate some sort of max runtime. Because, sometimes with PHP, if it's been running for days at a time, you can get some weird behavior in the past. And that's gone away more with the later versions, but it's just kind of a habit, and I think best practice say, hey, you can run for an hour or so. And then I typically like to add a random amount of time to that, so not all my workers are synchronizingly stopping at the same time. So they'll kind of just filter themselves out as you go through. Okay. All right. So the anatomy, I told you I'm jet lagged. The anatomy of a Beanstalk job, and basically what makes up a Beanstalk job are 4 pieces of data. You have a priority, which Beanstalk will make sure to use. Things that have a higher priority will go in, will be picked up by a worker before those with a lower priority. One awesome feature I love is the delay. Let's say I have a blog post, and I know it takes about 1 to 2 seconds to make sure it replicates across all of our slaves in the other database, in the other data center or whatever. So I can say, hey, I want this job to go in, but wait 2 seconds before you start churning away to make sure the replications worked just fine. Time to run is basically saying this job should take about this much time to run. And then if not, it has a way of putting that job back into the queue if the worker doesn't report back. And then you can pass along some data for that job. Typically what I use is I'll just use a JSON encoded string saying, here's the information for the job that you need. Put that in this, pass along as the data, and the worker can grab that data and JSON decode it. And also, if you guys have any questions at all, feel free to stop me, interrupt me, and let me know. Okay. So with Beanstalk, you have several actions that you can do on a job. You can put a job, which is basically creating a job, and you put it in what Beanstalk calls a tube. I call them queues just out of habit, but Beanstalk refers to them as tubes. So you can put a job in a tube, and you can put it in there with a delay. And then on the worker end, you say, hey, I want to reserve a job, saying I'm going to get a reservation for this job, meaning I'm going to do the work for this job. And then either I have two options. Either I'm going to go ahead and release the job, saying, hey, for whatever reason, I wasn't able to perform this work, put it back in the queue. Or I can delete the job saying, hey, job was completed just fine. You don't have to worry about it anymore. You can release with a delay. Another example is if I grab a job and say, oh, the data hasn't replicated yet, or the image isn't on S3 where I need it yet, go ahead and put the job back in and wait 10 more seconds or 5 more seconds before trying to do it again. And then you can bury a job, which is saying there's something wrong with this job. So put it back in the queue so you know that this job exists, but bury it so it won't go through to another worker. And that way an admin or some other automated process can go in, inspect the job, and handle it. And then you can kick a buried job back into the queue, and then you can touch a job saying, hey, I'm a worker, I'm still alive, I'm doing fine, it's just taking longer than I thought. I'm letting you know that I'm still working on it, so don't worry about putting that job back in the queue because I haven't responded. Yes? Ooh. I don't believe so. That would actually, in that case, what I would do is I would delete the job and put it back in. Yeah, or you could put it back in then delete, depending on what kind of. Yeah, there's that split. Yeah, there's that split second. Man, I don't think you can do that. That'd be a cool feature, though. I might look into that. Maybe I'll do a pull request. Awesome. Any other questions? All right. So this is typically, it's very, very simple. The client will create a job with a put. That job will be reserved by the worker. It will retrieve that job. Did I use the wrong timing? Retrieve. I did. It's supposed to say reserve, not retrieve. And then after the worker's done, it'll delete the job and poof. That's the basic flow. The possible flow is a little bit more complicated, but it's the same thing. You can put a job in, and then you can reserve it, and then you can release it back, or you can bury it, or you can delay it, or you can delete it. This is kind of the whole workflow. I won't go through it. It's pretty straightforward, but this is one last thing. Before I used to use Redis and lists in Redis to do queues, and this handful of feature set that Beanstalk has makes using Beanstalk really, really nice to manage queues. All right. Let's actually look at some code. This is the fun part. So let me mirror this because I cannot look behind me in. Okay. All right, awesome. Okay, so what I have here is my application. I'm regretting using Bootstrap. It's really bulky on a small display. Can you guys see this all right? Okay. All right. So what I wanted to do is I wanted to make an application to simulate some sort of jobs. And so when I was making this, I thought, it'd be cool is if I could pass in a list of words, and then I could have workers that will take those words, go hit an API for a dictionary definition, and then return. What I found out is that there's actually, I was unsuccessful in finding a good API. I found a terrible one from dictionaryapi.com that's XML, and I made it work, hacking work, but you'll see it's kind of funny. So what this is I have a little control panel here that has workers, let me move this over, 1, 2, 3, and 4, and they're all running on a Vagrant machine right now that I have on my environment. And they're listening on to a Beanstalk tube or a queue, and they're waiting for a job. And if I come down here, and I see this little line, I'll scroll up a little bit more. The gray fox jumped over some dumb fence. Isn't that how it goes? Something like that. I'll go ahead and submit those definitions, and I have an API that pushes that to the queue, and then independently, workers 1 through 4 will each grab one, go hit the API, come back, return this result, and store it in a Redis list that I can go and query. As you can see, I couldn't quite figure out how to parse the definitions very well. It was actually super, very complex XML. And so I told it, give me the longest definition for a word, which returns some interesting results. Like if I look up boring, I'll submit. Let's see if it'll work. A causing boredom, tiresome, a boring lecture. Maybe the API is trying to tell me something. Presenter. And if I spell something wrong, you guys can to make a presentation. All right. Anyway, so it's really, really simple. And so this project's up on GitHub. Everyone can feel free to check it out. I will say one word of warning. To quickly get it to work, this whole front end using this is using Backbone. This is using Backbone and stuff. This is a terrible way to use Backbone, so don't look at it as an example for Backbone. I was hacking it together last minute. I tried to use Ember, and I realized I had to understand Ember better to use it, so I hacked together Backbone. And so don't use it for a Backbone demo. If you look at this code, you'll die. But we'll take a look at the code for the worker. All right. Okay. So in this project, I have my little CLI directory. I have my worker, and in fact, I'll show you first how those workers get started. And so if I go into my Vagrant folder, okay. All right, so I have a supervisor, and what supervisor basically does is just a way to manage processes. And be able to say, execute this at a certain time, or make sure these are running, and if they exit, go ahead and restart them. And the nice thing is if you start and they exit immediately, like under a second, you can figure that. You'll say, oh, if it does that 5 times, I'm actually going to stop, because something looks like it's broken, and I don't want to completely jack everything up. And you can have it alert you and do all sorts of stuff. But basically, all I have is a configure. It says, hey, go ahead and run this command, run PHP. Here's the URL for, or the file for the worker. Pass it the processor number, like 1 through 4, and go ahead and make sure that's always running. And so if I was to actually come in here, grab this, and pass it like 5, I actually should be able to come back over here. Yep, worker 5 just showed up to work. And you can see it connected, whatever, and it's waiting to begin to run. I'm actually going to come in here. We'll look at presenter a bunch of times. Some definitions. Oh, this is different. I wonder what I'm doing differently in this than in here. Ignore the bug. But so it's sitting there, and it's trying to wait, grabs the job, just says, okay, presenter, and continues on. So, if you look, all this worker file is, there's things like with Symfony you can write, there's cool CLI tools and things. I don't want to use any of that because I just wanted to show the theory really clearly. But if you're working like in Symfony, go use the Symfony CLI tools, it'll be awesome. I just wanted to keep this really lightweight to to say this is what kind of the very basics. And so my worker will start. I'll change directory to wherever the directory is defined, as the file is, just to make sure I always have the same working directory that I'm expecting. I'll include the composer autoloader, and then I have a config file, which all it does is define the dictionary API key for this terrible API. I'll show you guys maybe one of the responses you get back from it, because it's really, really ugly. And then I define a demo worker class. And so I'll skip to the bottom real quick, but I just have this class. And then ultimately what I do after I define it is to say, hey, create a new worker, pass it the ID I passed in the CLI parameter, and then tell it to set up and tell it to run. And so if we come up here, and if I'm scrolling too fast through the code, yell at me so I slow down. If we take a look, I have some members of this class that just store some data for us. And the first thing that happens is when I construct, I go through, set the worker ID, I log out saying, hey, I'm starting up. I assign a worker hash. I find that's actually very helpful. This worker hash is unique for every worker. So if I look at like worker 1 and I see that hash is changing like every 10 seconds, I'm like, okay, something's kind of weird with this worker. That's actually keep restarting itself. So it's kind of when you're trying to debug, it's just kind of convenient to have. I pass what time it started, and then I figure out how long I want it to run, saying I want a maximum of 1 hour, and then maybe adding an additional 0 to 30 minutes. That way they don't all exit at the same time. And then I just calculate the end time. Then I go for my setup. I find it's really clean to kind of break this apart. My setup is basically go out and make whatever connections I'm going to need to do. I could connect to MySQL, or I could connect to, and here I'm connecting to my Redis server and my Beanstalk server so I can listen. And then I say, okay, I've gone through and I've finished. One nice thing is I have what's called a worker version that I set in Redis, and it's just an integer. And what I do is if I increment that number, every time the worker loops through its process, I check that worker version. And if it changes, I say, okay, I'm going to stop running. That way it's very clear. That way I have control to say, hey, if I've pushed new code for my worker, I want them all to load up that code. I want to be able to tell them, hey, I need all of you to restart again. And so it gives me a little bit more control over my workers. Okay, so I do my setup, get the current worker version, and then I say, okay, I want you to actually run. I have a giant try-catch around everything, just in case if I get an exception that I wasn't expecting, so I could log it and then exit gracefully from my worker. And then the magic happens right here in this while loop. And it's basically, when I construct my worker, this is set to true, and as long as that's true, my worker will loop through this while statement indefinitely, which fits right from here down to here. And so if I don't tell it to exit, in theory, this could run for hours and days and weeks and months and years. I don't know if I've ever had a PHP application run for at least a single instance of a PHP application run for a year. I'm sure it's happened. But in theory, it'll just run until I tell it to stop. And so what I do is after I run, I say, hey, set my status to I'm listening and report that status to Redis. If I look at my report function down here, it's just really simple. I just pass the JSON encoded string to a Redis hash saying, here's the status for this worker ID. I pass in this information and set that in Redis. And then I do this Beanstalk, and then I tell it to watch the system queue, which is I use for kind of system like important jobs. The order of the tubes or queues that you list is what they listen to in order. And then I want to watch a queue. I called it queue. I probably should call it something like words or definition lookups, but I just called it queue. And then I say ignore the default queue, because if a job is passed to Beanstalk without a queue explicitly set, it'll just put it in one called default. And typically if that happens, in my case, it's a bug. I don't want all my workers getting interrupted by these kind of weird, buggy jobs. And then the important part is I say reserve. It says, hey, try and reserve a job, and wait up to at least 10 seconds for a job. And so it'll go make the connection, and hey, do you have a job? If so, it'll immediately return, and I'll continue through my program. And if not, I'll just sit there waiting for 10 seconds. And immediately, as soon as the job's available for my worker, I'll grab it and I can immediately start working. And it gives a very responsive feel to your jobs. And then it'll return either the job object, if there was a job, or it'll return false if no job was available. If it's true, if there's a job there, I'll go through and I'll run my function called process job. And if not, I will just go ahead and I do an echo period just to, that way when I look at my logs, I can see if the worker's frozen somehow, or if I see the periods, I'm like, okay, I know at least it's still running. And then I report my status, and then I do a check status, which is this little bit of functionality down here that says, hey, if I'm past my end time, I want to go ahead and set run to false. If the worker version is updated, I want to go ahead and set run to false. And you could add other sorts of checks or things that it could do. You could even do things like cleaning up connections. Like if your MySQL server doesn't like real long running connections, you could check, make sure your MySQL connection is good. If not, restart it. And then continue on. And so it will sit here looping through this while loop until I get a job, and then I'll process that job. And the process job is really simple. I could use some cool reflection to automatically detect the name of the job, but since it's a demo, I thought I'd just explicitly do a switch. If it gets past like a restart job, that way you could actually pass in, like in the system queue, I could pass in a bunch of restarts to say, hey, go through and restart yourselves. Or I could do, or I have a job, which in this case I call it lookup word, and it'll go ahead and call up the lookup word function. And here's the awesome parsing of this XML. So I go ahead and get the job details. I pull the word out of it. I'd set my status to working, saying that way my admin panel can know, hey, I'm actually processing a job. And then ignore this part. This is really ugly. I don't like XML APIs, especially ones. I think that their API was meant to be used with an XLST to print a actual dictionary. So it was very, very ugly. But basically, I'll go hit the API, get the longest definition, and then JSON encode it, and then I'll go ahead and push that. And then I tell Beanstalk, hey, this job was successful. Don't worry about it. And that way it won't put it back in the queue. And then I wait 2 seconds so I don't overload the dictionary API. And that's about it. It's really, really simple. And so if I come over here to my demo right here, so what I have here is worker 1 and 2 are being managed through Supervisor. Worker 3 and 4 are being managed through Solo. Well here, I'll show that in a second. And then worker 5 is this one right here just in my CLI. And so if I issue a restart, all of them will be waiting there for up to 10 seconds. And then once they're done, they'll go ahead and restart. As you saw, these two changed their hashes and came back immediately. So we didn't even get a chance to see them offline. That's why Supervisor is really, really nice if you can use it. Worker 5 went offline, and it's not going to go back online until I hit up and enter. And then workers 3 and 4 are managed through Solo, which is a more hacky way of doing it, but if you don't have complete control over your environment, it works pretty well. So if I tell one more restart, let's see if these guys will go offline. Maybe. Yeah, it went offline, went back online, new hashes. Worker 3 or 4 are offline still, and worker 5 is offline. So Solo works with the cron tab. Nano, I guess. And all it does is it's basically a Perl script that will use a port, an unused port to lock that port. And so it'll go and say, hey, run this command and reserve this port. And then if it runs again and that port's already in use, it knows, oh, that's already running. Go ahead and wait. And so every minute, the cron's running and saying, make sure that my worker's running or not. And if it dies and exits, up to a minute later, it'll run again and it'll work. This works really well if you don't have awesome control over your environment. If you have access to like a cron tab, but not like you can't install packages. But if you can use Supervisor, use Supervisor. As you saw when I restart my applications, these worker 1 and 2 come back immediately, and worker 3 and 4 take up to a minute. All right, any quick questions about what I've shown? Any questions at all? All right, what time do we, I didn't look to see what time we get done with. So if you want, you can go, if I can get why is it not? All right, I have this PHP Worker tutorial. This will explain how you can go ahead and set all this up. You can check out the code, and then it uses Vagrant, and so you can literally just clone the repository, run Composer, set up your config file, run Vagrant, and it'll work. And so we'll hurry and finish the rest of the slides real quick, and then we'll be good to go. Okay, so we've talked about the theory of workers. It's pretty straightforward. It's not rocket science. So what about the high performance part? Like why, how can I, achieve high performance using this? Basically, when it comes to performance, writes, in a lot of ways, or communication can take a lot of time. And if you have a very write-intensive application or it does a lot of calls to other external APIs or whatever, it can always typically become very slow. And so what you want to do is, first of all, you want to make writing to your queue extremely fast. Beanstalk, by default, is in memory, which makes it very, very, very fast. If you need your jobs to be a little more durable and survive a reboot, you can run Beanstalk, where it will have a binary log. That way, if it restarts, those jobs won't just disappear. Typically, what we do is we have a Beanstalk server with the binary log that the really important jobs that we don't want to lose go into, and then things like warming the cache, pre-generating some images, sending our newsletters. Like, for example, sending our newsletter emails go into a Beanstalk that doesn't have a binary log, that's just in memory. And then our welcome to the site registration emails go to one that does have a binary log because you don't want to lose that. Or reset your password emails go to that one. But you want to make writing to your queue very fast. And then in your individual requests, for your PHP application, you want to just do whatever you must. And then if you can, queue all your other kind of I/O operations. And allow workers to go ahead and perform them instead. That way your users will have a very clean, crisp experience, and then you'll be able to scale whatever operations you have in a much more manageable way. Basically, my rule of thumb is caching is for reads, queuing is for writes. At work, we have an unusually high amount of traffic for our websites. Typically, like a local TV station doesn't get 600 million page views a month. But when we turn logging on our servers just to the disk, we'll fill up our disk drives in 6 hours. And so what we do is we go ahead and queue almost all of our log entries, and then a worker goes through and pipes that into a much larger place that it's okay if it takes it 5 minutes for an entry to make it into a file. But that's kind of the methodology. So you can look at logging, analytics. If any of you are doing like analytics in like a database where like every time something happens you insert a record, update a record, that can get insanely slow. Some of your queries you probably could queue. The generation to figure out related posts, you probably could queue that. Communication with other APIs, definitely. Especially, for example, if like an API of a vendor API goes down for 5 minutes, that way it doesn't wreck your application. All those jobs can get queued up, and then when their API comes back online, you can go through and process them. And even write in some of your different types of data sources. We have large Solar clusters that are work for searching, and we queue all of our updates to Solar. So identifying what to queue. If you haven't used XHGUI or XHProf defined, if you've never used those before, check them out. They're way awesome. But it's really good to find slow parts of your application. You can use statsd and graphite to gather kind of more broad stats across your application. And then if it communicates with anything else, if it has to talk to a different server or different, whatever, different application, there's probably a good candidate to see maybe want to queue it. Now, you don't want to queue 100% of everything you do, because then you'll make a very unwieldy application to manage. But you can probably find things that, hey, these can happen asynchronously apart from our requests in our application. All right. Thank you guys for having me. Thank you for putting up with my jet lagginess.